And so number 1 from the 2007 Advanced Higher Maths, a binomial expansion. Simply take this and expand it out into all 5 terms. Well, there's something you could do first of all, which is, if you've got an expression like this, which has got variables in both parts of the binomial, you could extract the worst of them. You could extract that fractional part by taking out 1 over x. If you took out 1 over x, that means that everything that's left inside the bracket will now have to be x times bigger. Then you would have x squared minus 2 inside the bracket. So instead of having some power of this, as in this case power 4, you'd have power 4 of this. So that's power 4 of that bracket, which wouldn't be quite as tedious to write out because there's no fractions to keep repeating over and over again, since they've been extracted in a oneer, because that will also be to the power 4. And then once you have that expansion, then simply divide all the terms by x to the power 4. Well, no bother. So back to this then. What have we got? So expanding this, so I can either put down the coefficients formally as the binomial coefficients, the combinations, or I could put down Pascal's triangle. What I'll do first of all is I'll put down the coefficients formally, so that instead of NCR, I'll put down the bracket notation for it. There are 4 brackets, so that's a 4 that goes to the top because there are 4 brackets to choose from. And if I'm going to start off by picking all the x's from each bracket to produce an x times an x times an x times an x, that means I'm going to choose none of the second term. So that's like saying how many ways are there of choosing none from 4. So I've got x to the 4 times the second part of the binomial, that'll be power 0. I could put a bracket around that, but I don't think I'll bother. Then you continue the same with the next one. 4, 1. Now choosing x from 3 of the brackets. So that'll be choosing, whoops, that from one of them, and continue the same. 4, that'll climb to 2, that'll drop, the next one will climb, and so on, until eventually the powers of x drop to 0, and the power of the second one climbs to 4. And then I could evaluate all of those and write them down. But I'll not. No, I'll just use Pascal's triangle after all, because that would be so much simpler and much more obvious when it's just 4. If there were large numbers, I might resort to the proper binomial coefficients. But when it's only a small number like 4, you can remember them easily. 1, 3, 3, 1, 1, 4, 6, 4, 1 and so on. And if you didn't, it wouldn't take you long to write down Pascal's triangle simply by adding those numbers always into the middle. That's 4, 6, 4, 1. So I just need the coefficients 1, 4, 6, 4, 1 in front of each of these. So I'll do that instead. So I've got 1 times the first to the power 4, the second one to the power 0. Then up to 4 times that drops, and this climbs. Now 6, that drops, and this climbs. Back to 4, that drops a bit further, that climbs a bit more, climbing mean goes up, and finally 1, that goes down to 0, and then that finally climbs up to 4 to finish it. And then just tidy up what you've got then. So anything to the power 0 is 1, so it's just one of them, so that's x to the 4. Negative 2 times a 4, that's negative 8. X cubed divided by an x, that's x squared. Negative 2 to the power 2 is 4, times 4, 6 is 24. X squared over an x squared will just be a 24. Negative 2 cubed, that'll be negative 8, times 4, negative 32. X on top, x cubed underneath, so overall x squared underneath. Negative 2 to the 4, that'll be 16, positive 16, and all x to the 4 underneath. There it is. And there it is. Not an awful lot of thought for 4 marks.